Good morning, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we're Backyard Musing, Science and Technology channel.
Yeah, thanks for joining us. Thanks for subscribing, leaving comments. We really appreciate it. And yeah, today we're talking about probably our most favorite mutual topic, and that's space. So
Yes.
we're going to get right into
New,
it.
new evidence suggests that Mars may once have had a warm and wet climate billions of years ago, offering a very different picture from the long-standing view that the planet was mostly cold and icy. This shift in understanding raises important questions about whether early Mars could have supported life. The question of Mars' past habitability has been studied for decades. Like Earth, Mars formed about 4.5 billion years ago, and scientists divide its history into distinct geological periods to better understand how its environment changed over time. Would you like to know more?
So much we do not know. So much. The latest research focuses on the Noachian epoch, which lasted from roughly 4.1 to 3.7 billion years ago. This period coincided with a late heavy bombardment, or LHB, a phase in solar system history marked by frequent and massive meteorite impacts that have affected many planetary bodies. So it could have been it, right? I mean, it could have been life there, and then all heavy bombardment broke loose. So
Yeah, it sounds like because it was 4 billion, maybe that was it was still forming. That
yeah,
planet was still forming.
yeah.
Among the most prominent remnants of this violent period are the Hellas and Argyre impact basins. Each spans well over 1,000 miles and is large enough to contain more water than the entire Mediterranean Sea.
Hmm. One might not imagine such a time being conducive to the existence of fragile life forms, yet is likely to be the era in which Mars was most habitable. Evidence of landforms sculptured by water from the time is plentiful and include dried up river valleys, lake beds, ancient coastlines, and river deltas.
And we're showing that to you on the screen right now.
Yeah, that kind of looks like part of the area that we live in.
Yeah. The prevailing climatic conditions of the Noachian are still a matter of intense debate. Two alternative scenarios are typically posited: that this time was cold and icy, with occasional melting of large volumes of frozen water by meteorite impact and volcanic eruptions, or that it was warm, wet, and largely ice free.
Hmm. All stars, including the sun, brighten with age. In the early solar system, during the Noachian, uh, the sun was about 30% dimmer than it is today. So less heat was reaching Mars and all the planets. To sustain a warm, wet climate at this time, the Martian atmosphere would have needed to be a very substantial, much thicker than it is today, and abundant in greenhouse gases like CO2. Oh boy, maybe that's what ended it all. Climate change. Yeah.
But when reaching high enough atmospheric pressure, CO2 tends to condense out of the air to form clouds and reduce the greenhouse effect. Given these issues, the cold, icy scenario is perhaps more believable. One of the main science goals of the Mars 2020 Perseverance rover, which landed spectacularly in February 2021, is to seek evidence to support either of these two scenarios. And the new paper, using data from Perseverance, may have done just that.
Perseverance landed at the Martian location of Jezero crater, which was selected as the landing site because it once contained a lake. Views of the crater from orbit show several distinct fan shaped deposits emanating from channels carved through crater walls by flowing water. Within these channels are abundant deposits of clay materials or minerals. Sorry.
So I was just thinking of
That's interesting.
they have an orbit of Mars, a satellite that is taking measurements and photos of the surface of Mars as it's going across Mars, right? Why don't we do that for the other 8 planets? Except, I mean, other 7. We do it. We have Earth. We know Earth intimately,
Right.
mainly, mostly. Why don't we do that for the other 7 planets and just start sending that telemetry back to Earth so we can study it and learn more?
Yeah, I don't know. Because again, this slide that you have up here right now, that looks like it could be landscape from parts of the desert Southwest.
Nevada.
Yeah,
Nevada.
yeah,
Yeah.
fascinating. Looks like
Huh.
decomposed granite there in the background, like we
Yeah.
have around here in our hills behind your house.
Yeah.
And yeah, it just very similar.
The new paper details recent analysis of aluminum-rich clay pebbles called kaolinite, Kaolinite, located within one of the ancient flow channels. The pebbles appear to have been subjected to intense weathering and chemical alteration by water during the Noachian epoch.
Well, this is perhaps not surprising for a known ancient watery environment. What is interesting is that these clays are strongly depleted in iron and magnesium and enriched in titanium and aluminum.
This is important because it means these rocks were less likely to have been altered in a hydrothermal environment where scalding hot water was temporarily released by melting ice caused by volcanism or a meteorite impact.
Instead, they appear to have been altered under modest temperatures and persistent heavy rainfall. So they had weather. The authors found distinct similarities between the chemical composition of these clay pebbles with similar clays found on Earth dating from periods in our planet's history when the climate was much warmer and wetter.
So remember when we said in this paper here that the sun back then or today is 30% more light. So it's dimmer by 30% back then, billions of years ago.
Yeah.
I wonder, are we over the halfway mark? Have we reached over the halfway mark yet with the brightness of the sun? I wonder. That's an interesting question.
Yeah, good question.
Huh. The paper concludes that these kaolinite pebbles were altered under high rainfall conditions comparable to past greenhouse climates on Earth, and that they likely represent some of the wettest intervals and probably most habitable portions of Mars history.
Furthermore, the paper concludes that these conditions may have persisted over time periods ranging from thousands to millions of years. Perseverance recently made headlines also for the discovery of possible biosignatures in samples it collected last year, also from within the Jezero crater. And that's
I've got that up on the screen right now.
Yeah, fascinating colors.
Yeah, I know. Yeah. But I wonder why is it just colored on like the right side, but it's gray on the left? I wonder. I have
I don't know.
idea.
Those are deposits of certain type of minerals, or I don't know.
Yeah. These precious samples have now been cached in special sealed containers on the rover for collection by a future Mars sample return mission. Unfortunately, the mission has recently been canceled by NASA. And so what vital evidence they may or may not contain will probably not be examined in an Earth-based laboratory for many years.
I wonder why that is. I wonder why they did that. Crucial to this future analysis is the so-called null criterion, a concept formulated by astrobiologist Andrew Knoll, which states that for something to be evidence of life, an observation has to be explicable not just explicable by biology. It has to be inexplicable without it. Whether these samples ever satisfy the null criterion will only be known if they can be brought to Earth. And well, it doesn't sound like that's going to happen anytime soon, unfortunately.
Yeah, I wonder if it just got the budget cut. But I was thinking, thought just came up. You know how Artemis 2, the crew, they splashed down in the ocean?
Yeah.
Well, there's no ocean on Mars.
Correct.
So I think we have to crack that code. You know, like in sci-fi movies, the spaceship comes in, goes through the atmosphere, and then lands on the planet. So we're going to have to figure out how to land on the planet without a landing pad, you know? I think SpaceX is working towards that.
I was going to say, even SpaceX has to have that body of the rocket returns to its origin. It's like, it doesn't just land in the middle of the desert someplace. So yeah, somehow they're going to have to figure that out. figure out a landing strip or something. Maybe they can use like a space shuttle type craft, that they can land and take off. I don't know.
Plus, now you have to have enough fuel to take off and get away from the gravity of Mars and get into orbit and then make it back to Earth. I mean, so.
And that's pretty critical, right? I mean, if you get down to, because I've heard about other space missions that have had, they've been on the verge of having to abort because they weren't going to have enough fuel to be able to take off and return. Apollo, there was a couple of Apollo missions like that.
I could see like they're tugging it with them to the planet, and then it stays in orbit like a big extra fuel tank, right? They get down, collect the samples, do whatever they got to do, then take off, get back to the habitat or whatever, and now they add more fuel to get back to Earth. They've got the fuel. I could see that.
Yeah, like a mini mothership or something.
Yeah, like
like the Apollo
International Space Station.
Yeah, they had, because they had the lunar module, and then that broke away and took off, and then it redocked with the main capsule that that they eventually came back to Earth in. So, yeah.
Okay, continuing on. Either way, it is quite striking to imagine time on Mars billions of years before the first humans walked the Earth, that a tropical climate with possibly a living ecosystem once existed in the now desolate and windswept landscape of Jezero Crater.
There you go.
Yeah. Interesting. I think it's interesting how they hypothesize these things based on the pebbles and stuff. What could have caused that pebble? Well, rainfall, not hydrothermic, volcanism. I mean, we can look out in our backyard and see, the effects of volcanoes and volcanic rock.
Glaciers, seabeds. I mean, all this area around here used to be underwater at one time, they say. So I believe them. So, yeah, it's fascinating stuff. So, but when you see it on a planet like that, that's, a few miles away, that's pretty cool when it looks similar. So anyway, thanks.
We'll see you in the afternoon.
Take care, everyone.